Hi, welcome to this Open Security Summit session in January 2022. And we're basically going to be talking about some of my favorite topics in the world, which is threat modeling, especially threat modeling with code. So over to you, Petra, so you can show us your latest thinking and the evolution of this very important topic.
Cool. So hi, everyone, and thanks for coming. Marius and I are here a little bit to share our insights into threat modeling. It will be threat modeling as code from my perspective and some challenges that we face with threat modeling by Marius. To start with the threat modeling as code. Sorry, 1 second. So before I start that, I just wanted to introduce myself. I'm a senior cybersecurity engineer at Zava. Those who know me, I also used to be a cybersecurity engineer in Glasgow. And I am very passionate also about threat modeling, application security, cloud security, and I do love to do these little talks on the Open Security Summit because, like Dennis said, this is a great way to share the knowledge. Right. So to talk a little bit about the threat. Oh, sorry, I skipped something. Marius, introduce yourself, please.
You skipped me.
Yes.
Hello there, I'm Marius. I'm the CISO at Zava. I won't go through a list of all my security credentials, which mostly expired by now. I will just give you some fun facts about me. I'm dyslexic, and I really don't like presenting. It poses a challenge for me. And Petra joined Zava 2 weeks ago and has already been challenging me to present. So here I am. I'm colorblind, so there's a lot of numbers there that I can't see, most of you can see. It's a nice icebreaker when people ask me, what color is this? And I love theoretical physics. I'm an engineer and a hacker at heart, so I like to break things. I like to think with mindset of the hacker. So I really, really enjoy the threat modeling aspect because it gives me the opportunity to break the functionality of what the developers or anyone is building. That's me. Thank you.
All right. So about what we're going to talk now in the next about 45 minutes is threat modeling as code. I'm just going to go through a little bit of the existing frameworks, the principles, why we want to do this with code and how we're going to do it. And then Marius is going to take over and just talk a little bit about the threat modeling challenges that we can have as security engineers. So to talk about the threat modeling as code, we have some existing frameworks already. I don't know how much everyone is acquainted with them, but we have PyTM and we have ThreatSpec. Now, these frameworks are already existing and they're in Python. You can look at them through these GitHub repos. However, there is a few challenges with them. And the thing about them is that when you go into these frameworks, there's a lot of skill and a lot of, it goes down to a lot of detail to actually execute them. So on a level of maturity, when you have a very mature threat modeling implemented in a company, and when you have your devs already doing it and very well acquainted with your threat modeling strategies, then you can try and introduce these. But when you still are in a phase where you're introducing threat modeling and when you still want the buy-in from the devs, it's better to go for a little bit of a less intense approach. And therefore, I made this hybrid model, which I'll present soon enough, where the whole concept threat modeling as code is there. And I'll explain how I mean that. But also, it's not just code. There's also the classical theoretical part of that too. And this hybrid can help bridge the gap between the security team and the dev team. Now, the pros of these frameworks above, and also the pro, I would say, of the hybrid framework as it scales better. And it goes much better with hand in hand with agile development. So let me say Also, by the way, if anyone wants to ask any questions, please feel free to interrupt me and ask, or post it in the chat. Yeah, so the process and the principles of this. The way we do it is that we keep the threat models in the repos. And why? Because that way it's very close to the developers, and that way it's close to the code. So the developers approach the threat model in their own environment, and the threat model lives next to the code that it analyzes. So therefore, it's just better at bridging that gap that I talked about. Also, if we approach a threat model as code, the version systeming comes into place. And this is how we can easily track not only the changes to a threat model, but what is happening to our application and the evolution to the application itself. Because as you all know, a lot of times by having a threat modeling session, we actually establish the architecture of the application, because a lot of times the devs themselves are not really sure about the architecture. They're not really sure about the flows. There's some gaps in the knowledge. So by establishing a threat modeling session, a lot of facts get panned out, and you can create a really good document, and that describes not only the security architecture, but the whole architecture per se. So when you have a new iteration of that threat model, if you make a little change to your application, if you introduce a small feature, you also introduce this change to the threat model, and you create that as a pull request into your existing threat model. So when you check into that pull request, you can see the differences, and that's how you track the whole evolution of the threat model and the application itself. And this is why I'm an advocate of doing much more smaller threat models than a big one. You can create a big one that will comprehend the whole application, but then every other subsequent threat model that will just be addressing one part of the application, also depending on the complexity of the application itself, that again can be just another pull request that just goes into the big threat model and complements it. So you don't have this huge, threatening chunk of data where you can't really understand what's happening. And so that's also an option to do separate threat models as well. And you can do it whether in the actual repo where the code is, or you can do it in a separate threat modeling repo. It's kind of like depends on the complexity of the application itself, because a lot of times there's not a lot of repos, so you can just put in every repo its own threat model. But sometimes if a threat model comprehends multiple repos across the whole application, then you probably want to have a separate threat modeling repo. Right, so moving on. So as I said, why? Because it scales. Once you have a few threat models that you've done of your application, every other subsequent threat model will be easier, and you won't have to go through everything again, especially if you log the flows, if you log the facts, then every single iteration of the threat model will be easier and easier. And then you won't have to keep going back to the beginning, but you just create little pull requests on the original threat model that will show your change. And how, finally, so I'm going to demo you how I imagine this to be done. And yeah, hopefully nothing breaks while I do it, as on any demo. 1 second, I got this Zoom box that's in the way. How do I get rid of the, oh, there we go. Right, so I'm gonna go through my repo first. So this repo is basically the folder structure of like your threat model. That's how it should look like. So we have a README document that can be inside a threat modeling repo, or it can be inside a folder. And the README document basically just describes the whole process that I just said. So we trigger the threat modeling process with the design phase of the software development lifecycle. We clone this repo into a repo where the threat model will live. I meant folder. So bear with me, this is all new, so I'm going to go ahead and improve this later, but I wanted to have this ready, so at least there's a, there's something I can show to you guys. And any feedback also on this, please, send me pull requests, create issues. Happy for any participation. So yeah, so we create an environment for this. We communicate with the devs, get them to complete the threat modeling questionnaire, which I'll talk about later. We review the architecture diagrams and we trigger a session. Now, how to use this? So we need Anaconda for this because we're going to be using Jupyter notebooks, and we're going to create Anaconda environment with an environment.yaml file that's inside this repo, and we activate that environment that has all our dependencies that we need them. And then once we have done the initial assessment, we create diagrams as code, and then additionally, Wordly maps as well. Because we can use Wordly maps to create a strategy on remediation and risk. Now I'm going to go into the actual Jupyter notebook. So as you see, it's here, but what I'll do is I'm going to go to the Jupyter notebook on my screen. So this is how it all looks like. So this first piece of code is just to hide the input code what we want to present. If we want to present this threat model to like management or something, we can just hide all the code and it will come out nicely. I'll show that later. So the theoretical part of the threat modeling, and this is why I call it a hybrid, is this. So there's two parts of it, and I'm planning to separate them later actually into the prep bit and into the output bit, but at the moment it's all together. And what we do is we get the devs to complete all of these questions about their application. It doesn't have to be about the whole application. It can be just about the feature that we're threat modeling, because as I said, it's better to do a few small ones than a huge chunk one. So yeah, so we complete the whole thing here. We list the threats, but that's just from the developer point of view, what they think when they're coding the application. Do they think there's any threats to the application? So this is all like prep work, because also from the security side, once the dev has answered all of these questions, it doesn't have to be dev, it can be the architect or DevOps engineer, depending on what part we're modeling. So then as security, you can review the whole thing, and you can also come up with any follow-up questions, and you can list it all here. And this bit is actually the output, because after you do the whole threat model, you have your threat modeling session, you list here the threats, the risks, the actors, the controls. What I'm planning to do is also make it more into a table and put it at the end actually of the Jupyter notebook. So yeah, so that's how the theoretical part is, and this is all based on the OWASP threat modeling methods, and I've put here a excuse me OWASP cheat sheet that everyone can see as a reference. So yeah, so also here we can put the owners of the risks that we identify, we can put some controls that we identified and considerations. Also, what I'm planning to add here is facts, actually, because it's important to state some facts so we don't have to go back to those facts. For example, there might be a threat that we considered, but we decide it's not a threat because of some certain facts about the application itself, or some certain authentication, authorization mechanisms that are in place, for example. So it's good to log these. So if we do any subsequent threat models based on that, on top of that, that we can just come back to these facts and just say, well, this was already considered and it's not a threat, so let's move on. So once we have that, we get on to creating a data flow diagram. Now, ideally, we want the development team to start doing these. And actually, they should tie in with the architecture diagrams, because if an architecture diagram is done correctly, it will show some flows in the application itself. So this is a good way to trigger some good quality architecture diagrams if they're not already in place. So what we do is we use a library called diagrams, and all the dependencies for diagrams are in the environment.yaml file. So what we do is based on a Python code, we create a data flow diagram. It takes a little bit to learn. It takes a little bit to load all the icons. But once we have a few of these diagrams, it becomes really easy and straightforward from there. So anything that we want to add or change, we don't have to think about reassembling the whole diagram. But what we do is we just add our components, whether they're in a cluster, because putting them in a cluster will help us with trust boundaries as well. Because if we have like a couple of things that are inside one trust boundary, or if we want to even represent a Kubernetes cluster, we can all put like within the cluster, or they can be outside the cluster like these guys here. So once we have created a diagram, we can, and we've done our threat modeling session as well, what we can do is proceed to a kind of risk mitigation strategy. And we can do that by using worldly maps, also with code. So basically what we do is we go for, we use this little framework for worldly mapping in code. And again, list the anchors, list the components, capture the flows, and we have a worldly map. Now I'm going to execute this whole thing so that you can see what I'm talking about. Any questions before I move further? I guess that's a no. Let me just fix my camera. Okay, cool. So I'm going to execute everything. All right. So this is how it looks like, nice and clean when we execute the whole notebook. So then we have, as I said, the theoretical part, which I'm planning to divide in two parts, the prep part and the output part. And then we have our data flow diagram. So this is how it looks like when we use diagrams. As you see, the components are really nice and clear. We have some icons. You can even import icons. You can designate your trust boundaries as well. And you can even change the colors of the edges. And you can play around with that too. And then this is how our worldly maps look like. So in relation to that, the reason why I'm showing you this specific worldly map, even though I'm talking about creating a worldly map for, you know, a risk mitigation strategy, in this scenario, I wanted to present this specific map. And the reason why I wanted to say is why I also think creating these diagrams as code should be quite useful. And the reason is for the architectural team and any new development engineering on the application itself, we need diagrams. Also for troubleshooting, if things go wrong in production, we need good quality diagrams, right? As InfoSec, we also need diagrams. So therefore, in our worldly map, for those who are not familiar with worldly maps, we have as anchors InfoSec and architecture team. So these anchors have needs, and the needs are threat modeling and diagrams. InfoSec has the need diagrams of threat modeling. Architecture team and InfoSec, they both have, you know, diagrams as a need for threat modeling, or for the architectural team for, you know, further engineering efforts, troubleshooting, and so on. So therefore, we can see here that good diagrams can be obtained for, you know, from good architecture diagrams. And the way to obtain them is to have engineers create good diagrams by having those skills. Because sometimes, you know, engineers are brilliant at writing great code, but maybe not so great at creating good diagrams of the code itself, of documenting the flows, of actually visualizing the flows. Because some people are not even that visual. Some people are very contextual, so they can write brilliant code, but they can't visualize it all that well. So we need to teach them those skills. Also, there needs to be a, you know, a company drive and initiative to get those diagrams in place. So if we pull those two things to the right, which means that we carry them inside with their evolution, we carry them more to the right, which means we make them more commoditized, we make them more of a product, make them more mature. That means that our threat modeling, which is in the genesis phase, which is in the immature phase, can also be pushed to the right and make it more mature and make it, you know, more of a product and a thing rather than what it is now as you know, a bespoke creation. So this is what happens basically. This is the evolution that I wanted to show. If we make better diagrams, if we keep making these diagrams, and that's what I'm saying, rather make a few small ones than, you know, a huge chunk that nobody understands. We keep making them. And if we get the devs in a good place where they are actually able to make good quality, and we insist on that, we can actually get our threat modeling and data flow diagrams also in a good place. So to kind of capture the whole thought process behind this is a kind of a hybrid between, you know, classical threat modeling and threat modeling as code to bridge the gap between the security team and the devs to make it easier for everyone. We have, you know, a versioning system which captures our continuous risk assessment, our continuous threat modeling. No need to come back to old threat models. We just carry on top of that. We create multiple smaller threat models. Same for diagrams. We create them as code. And then if we want to zoom in on any mechanisms right here that happen, we can create a separate threat model on, you know, as a zoom in. But then it's easier because we already have the code for this big diagram and we don't have to do it all over again and change everything. And then also it helps when we have worldly maps as a strategy on how we're going to action this, because a lot of times there's threat modeling, which becomes like an academic exercise. We'll do it, but nothing gets done. So to help not only security, but the whole company, it's important to show why the action items from the threat modeling session are important and how they're going to help the whole company. So therefore, we can use worldly maps that can all be in this Jupyter notebook. So yeah, this is basically my little framework. As I said, please, you know, bear with me. I'm going to make it better. I'm going to work on some additional stuff. Feel free to put issues there, what else you'd like to see there, suggestions, or create a pull request. And, you know, I'll have a look and hopefully we can make it a collaborative effort. So yeah, any questions before I hand in to Marius?
No, this is really cool. I do feel like you know, I'm having deja vu in a lot of these conversations, Petra, which is awesome.
Yeah.
So I think one thing that would be really good is to also show lots of little examples, even from simpler to more complex diagrams.
Exactly.
Right? And
yeah.
Because I think the other thing that's interesting is that code that you have there can be refactored quite effectively, right? Because you can then even have patterns, right? And you can just, you know, import patterns, because once you got it into that sort of diagram as code model, like, you know, we can wrap a lot of things around it. We can make a lot of modules. So then you can, like you said, you can do the bits. Now, in terms of the output, so I may have missed it, but you have the information there, and then where do you store the actual items? You have a JSON or YAML file that actually contains the threads and
so my initial thought was to still store it here. So but not is this part. I was planning to make like a separate cell here at the bottom where kind of we have the output. And I was planning to store it also in MD format, but storing it in JSON is a very interesting idea, actually.
Yeah, you're gonna struggle to scale that. Also, because remember that the notebook, in a way, you know, you should avoid having a lot of code in the notebook. You know, it's great for the initial development, right? It's great for the initial bit, but it's almost like the natural evolution is you start a notebook, then you refactor into like behind, you know, modules, right? And eventually they should even be version controlled, right? They should even be, you know, full-on dependencies, right, of it. And I think you need to do the same thing with data, because one of the variation of this project, but I think this adds a lot of interesting parts of it, is to have YAML files, and sometimes YAML files work quite nicely, that get added to every repo, right? And those YAML files can actually go even for something like application inventory, or even understand what's going on there. But then you can add this information, you add the assets, you add the threads, you add the risks, right? So then you basically have this really cool flow where every repo, you almost have a folder, which you even call security or something, that, or threat models or whatever, you know, the culture you define. And inside that folder, you have all this basically core components, right? You got this, information about the application, information about what's going on, and that's the perfect place to put your threats, your risks, your assets, your kind of other set of security-specific metadata, right? That you want to do here.
Yeah, no, that's actually a great idea. And actually, your JSON suggestion can be coded into the notebook so that you create a pandas data frame with your, threat actors and everything, and then you create from the data frame, you create a JSON. So that's actually very doable. It's still inside a notebook.
But make sure you do a round trip. So in your environment, you want to be able to go, load the JSON to panda frame if you want modified. In fact, I know you guys never got into that whole edit UI that existed there, but there's a couple of nice even JavaScript frameworks that you can use to edit it, because you can see it eventually you want to manipulate it, right? So you kind of want to think of the round trip where I load JSON or YAML, right? YAML tends to be easy to edit manually. JSON tends to be sometimes well formatted, right? So there's an interesting balance there. You might even support both because they're very compatible. So you want to be able to load that YAML file, then present in a Jupyter notebook. If you want, allow it to be programmatically modified or made changes, but then save it back, right, into the same YAML. So the notebook in a way should not really have raw data, because notebooks are great to display and visualize and kind of do some manipulations, but they can get messy if you start to use them as a data storage.
I see. No, that's a good idea. I'll definitely work on that. That's another note there's a lot of improvements that need to be done on this. So I'm excited about every new iteration. So yeah, definitely great idea.
The other cool thing here is that when you publish this, what does it look like on GitHub? It should look good, right?
Yeah, so you can visualize pretty much everything. And even in version control, so I didn't do any pull requests, but I had a look in how it looks like in the visual code. When you do like a change to the actual Jupyter notebook, you can actually see the differences. So despite like that Jupyter notebook just looks like a notebook, you can still see it as code inside the version, like when you see the when you go into the pull request.
Yeah, so there's two things here. Scroll down. Do you actually see the diagram? Cool, that is really cool, right? So
can't see the Wordly map, unfortunately.
You
see the diagram.
And because that's an image, right? That has been exported as an image, correct?
Yeah, correct.
So so that's really cool, and that's why it's important to have a view of this that doesn't have the code, but is also very digestible. Because if I want to consume a threat model, you want to get to the point where I just see the outputs, right? Because that's what most people will consume. Because also remember that the objective of this is for the developer teams to use this as almost architectural diagrams, right? Because if they do it, then they start to maintain it. And eventually you get to extract this from the code, right? Which is
what can be done is from the Jupyter notebook, it can just be, we can create an HTML file that just then, automatically gets created.
Or a notebook, right?
In there.
A notebook, if you're using something like GitHub, it's not bad, as long as it's just the global output of things, right?
Notebook? You mean like?
Yeah, a notebook like this, but and that's why if you have, for example, if you then refactor a lot of this code, like you can change all that code to be one line, right? Because that line can just be output, graph, right? And then that looks nicely over there, but then
I see what you mean.
From a consumer point of view, I then just see the text, I see the descriptions, I see the information, I see the diagrams. So what you then start to do is somebody else can add metadata and context that is relevant to the diagram itself.
Yeah,
right?
I see your point, yeah.
Because one of the key objectives here is to make sure that we create artifacts that are almost created by the dev teams, or even more importantly, created programmatically. Because if you think about it, a lot of the stuff that you have now or some of the stuff you have on that diagram already exists in the Helm chart, right? Already exists in configuration files. So the sweet spot of this is start to then think about how can you create diagrams that are similar to this, that are actually created from code itself.
Yeah, that's definitely part of the evolution,
Yeah, it's not even what you think it would be, right? It's actually what it is already, right?
Yeah.
And some of these might come from AWS configurations. Like, you imagine, a series of Boto3 queries that go to S3, download metadata or grab metadata, and then create diagrams that tells you this is actually how the application works. And then you just add a bit of context, like the users and the stuff and the inputs and the outputs, right?
There is already a framework called Cloud Discovery that you can use similar way. So you make a call to AWS and it gives you like your VPCs, your EC2s, and all of that. So that's also something that can be used. Jacob, you have a question? Jacob?
I don't think you're muted.
Yeah.
That's a mute.
Okay. Right. Well.
Oh, sorry. Does he need? Is it okay, Jacob? Oh, wait.
He's got his hand up, so I thought he wanted to ask something.
Yeah. You should be able to unmute yourself.
Yep. Now it works.
Okay.
Right. Look. So you mentioned that after the threads are generated, a lot of them are similar for multiple projects, so you can make some reasoning out of it, right? You can make some statistics. You can propagate some threads based on what items are in the diagram, right? And it's a cool idea. It's something that we're working on as well. The thing is that to make some good reasoning out of threads, they need to be in a specific structure. And there are some ideas that are mentioned, on different talks at different conferences. Some companies use gherkins, for example, the structured way of expressing threats, so that later on they act as mathematical components that you can save in the database, compare one with another, and make the reasoning. So have you thought about this, or maybe have you find a way to save threads in a structured way, and what would that be?
So so that's actually one of the next steps, is as we discussed with Dennis as well, like once we have a format for threads, then we can also store it into like a certain JSON file or whatever. But like what you said is actually quite crucial. Yeah, if we have a good way to actually show the thread, then we can take this to the next step and to the next step in the evolution. So yeah, definitely the next thing to look into. As I said, open to contributions as well. So yeah, let's all work on this.
Yeah, and I've also heard that Arius Risk is working on some open threat model format, but they haven't published it yet, right?
They have some community edition, but it's quite limited, and their enterprise edition is quite expensive. So I looked into their community edition ages ago, and it's kind of similar to the Microsoft threat modeling concept, but I haven't seen if they had anything with actual code.
Yeah. The only thing I found is a GitHub repo, but there is not a lot of details there.
Okay.
Right. Thanks.
Cool.
There's a good question, Petra. Have you seen that about how the threat risks are determined from the use of this? Have you addressed that one? From Evan.
On threat risk.
Evan, you should be able to.
Oh no, so basically I wasn't using anything from PyTM or threat spec inside my Jupyter notebook. It's the threats would be determined on the actual threat modeling session. So I just listed those existing frameworks because I just wanted to mention them, because these frameworks do exist, but they might take a lot of effort from the engineering team and a lot of skill to learn them. So that's why I said I created this kind of hybrid model.
Yeah.
Sure. Hi, I'll just get my face on the screen so you can see who I am.
Yeah.
No, thanks for the presentation. It's been awesome. The reason I asked that question is there an intention to kind of have the notebook so that you effectively do this bit firsthand, and then when you kind of coordinate the meeting with the devs or the engineering team, that you then sort of plug in the threat risks so you can kind of populate them in the same notebook? Because I was just thinking if you could do that, then it's kind of like you've got your artifact there for that particular review. And then secondly, the other thing I was thinking about is it'd be really cool if we could then, I'm thinking ahead here, is just post that into to Jira to use it as like a risk management process. So you use it as a kind of threat modeling process, you document it, you visually see it and stuff. And then afterwards you kind of agree it and go great. And then, you know, you post it into your Jira board as and just triage it as a sort of risk management sort of process. That'd be really cool to see.
Yeah, I guess this is where Genesis Edit UI comes in, because if you plug it into Jira, you can plug a Jupyter notebook into Jira. So if you plug the notebook into Jira, you can automatically from there even create some like tasks and action items for the team.
So in fact, the first version that I did of this actually did that. We actually were using Jira to hold the components references, and then we're actually creating the graphs based on the relationships in Jira. Right. The bit that was missing a bit then was actually a good way to create better diagrams, because the diagrams need, and also when you look at creating maps from the diagrams, which is the next evolution, right? You need something like this. You need a kind of a programming model. And this is this is kind of, some of these stuff are recent, right? Like this is the new sort of generation of some of these APIs that really allow, that programmatic workflow to occur, right? Which needs to happen in an open source way, because we, in a way, if you think about it, what we're solving here is how developer teams document software, right? Like we shouldn't be shy about it. This is what we're doing here, because, when you start doing a threat model, what you're doing is you're mapping architectural diagrams, right? So for me, the sweet spot with this is to use security to drive the threat models, because that's an easier ask than getting teams to say, I'm going to document everything I do, especially because there's this crazy freaking concept in Agile that, or quick deliverables that, the faster you go, the less you need to document, right? Which is quite insane. So what I like about this is the fact that what is allowing us to do is now create these libraries and these templates. And then the Jupyter notebooks almost becomes what you bring to the sessions and then walk through everybody. And then eventually ask the really cool question, which is this correct? Right? And then and remember that question is important, not only when you finish a threat model, but 2 weeks or a month or 2 months later, when somebody finished implementing what was done, right? Because you could do a threat model based on what you think in the wishful views of what you think should happen. You need to make sure that it keeps being updated, or you have an easy way to review it.
Yeah, no, completely agree. Okay, let's go for a question from Izar, and then over to Marius. Don't want to run out of time.
Oh yeah, plenty of time, don't worry. You can keep going.
Okay. All right then. Izar, go for it. Another problem with the muting, I guess.
Oh, sorry. I thought no, my eyes are sure to do it. Yeah, he's unmuted.
Can you hear me now?
Yeah, we can.
Yes.
Oh, great. So, hi everyone. Hey Petra, thanks for the presentation. Really, really interesting stuff. Disclaimer: I am one of the PyTM developers.
Yeah, I know.
So the thing that I wanted to ask you is where do you see this effort going forward? Because correct me if I'm wrong. Right now, it's more of a documentation thing, right? Like wait, my Google Home here is going crazy. Stop. Yeah. So right now, it looks like it's more a way to document the effort, apart from the diagramming, which I can see at the beginning of the process. But where do you see the two evolving to?
Well, I think there's a lot of potential to evolve into, like, what we just talked about. So generating these outputs in a different format, and then using them as a direction towards risk management and risk strategies. We can then also try and create a framework where we can generate the threats automatically. But I think that will have to be also a bespoke thing. If we have already pre-generated threats from our own application, then how can we implement them to be pre-generated based on some information that we put? So there's a lot of ideas going forward. but I still haven't pieced them all together. And that's why I said this is a baby project in the making. And, I think going towards something like PyTM is the next step in the evolution as well. Because if you start making threat models like this, I think it's a good step towards something like PyTM or ThreatSpec, because then you instill that culture into the dev team, and then you can get them to actually start doing them themselves, without even the security team too much involved. So this is kind of what I saw as more of a bridge in the gap rather than the final solution.
Nice, really nice. Thank you.
Cheers, thank you.
And the other thing just is actually Petra, in projects like this, I think it's very important that we also spend a little bit of time making sure things are compatible with each other, and which is kind of why I like the idea of having the raw mappings and the raw data stored in YAML files or JSON files, because you kind of want to leverage the best of, for example, both worlds, right? So
Yeah.
as somebody creates a template, each of these brings things a little bit differently, uses a little bit of different APIs on the way to create some of the results. But we kind of need to start also arriving at a common way to represent threats, a common way to represent risks, a common way to represent vulnerabilities, almost like this graph schema that can then be imported. For example, like if you look at the way we use Jira, we use Jira as a graph database. So eventually there's already a common, something that is quite common on both the tickets, right? And I think we can agree on one of those, that, we almost use the file system schema as a way to make sure that we got something that is compatible with a lot of these different models.
Yeah, and if I can just complete that for a second, Dennis, one lesson that we have been learning with PyTM is that threat modeling is already seen as a very high friction activity in people's minds. We haven't yet translated it to, it can be something agile, it can be something quick. That's one of the challenges we're experiencing right now. And a lot of people say that if they have to spend time building collateral and putting things into specific formats and translating their ideas into some form of code or description or formalized language or anything, then that's already something that they see as slowing them down. So just something to keep in mind going forward as you develop this, that both in ThreatSpec, I think, both in PyTM and also in the playbook that Abhay wrote, lowering that barrier to entry for the developers is not only about expressing the system and expressing the threats and expressing the findings, it's also about what they have to bring into the room with them.
Yeah. I think that's a super critical point. That's why I think that the first audience for this is almost the security professionals that are already doing the threat models.
I would say the closer the tool is to the developers, if it's GitHub or some notebooks that they're already using, the better, because ultimately security teams, they can't produce threat models for every project or for every change that the developers are doing. Actually, the best way is to allow simple threat modeling by the developers themselves. So
yeah,
in that way, that direction
absolutely
is actually
absolutely. But remember that if you can't get this used by the current security professionals that are doing threat modeling, something is wrong, right? Because if you think about it, if it's used by the security professionals, they do threat models, they present to developers, there's a moment where it should be easy for the developers to start using it. So even if the first generation of developers is given a template and a structure, the model, the model is working when that clicks in. Then the question is, can you reduce that initial onboarding, or can you create enough examples so that for the next team, they don't start from zero, right?
I agree here, but at the same time, the way security professionals do threat modeling and the way we can teach developers to do threat modeling are two different things. Because if somebody who has been doing threat modeling for tens of years wants to do the quickest threat modeling with the highest possible, the best possible outcome, they'll just take whiteboard and they'll just start writing down threads, right? If we want to do it at scale and make the developers do majority of the work, then they can't do it because they don't have all of these attack vectors in their minds. We have to put this level of abstraction and suggest them some ideas or introduce frameworks that they will be able to translate their thoughts into the actual threads.
Yeah. So guys, because you started talking about the challenges anyway, I want to steer the conversation towards Marius, because he's got also quite a lot of interesting points about the challenges of threat modeling.
Yeah. So while Marius loads up, you know the logic, and Marius, please start sharing your screens, right? You know the interesting thing of what you just said. You're saying that, look, you know, we if we go to this threat modeling team and they're more comfortable doing whiteboards, right, than using something like this. For me, what you're telling me is that part of the problem is the threat modeling team, right? Because, you know, yes, we want the developers, but imagine being a developer in that environment where you're trying to do threat modeling as code and your threat modeling team is not on board. So what you want is somebody like Petra that already feels the pain, who's already wants to do threat modeling as code and is basically willing to work to get there. Which let's be clear, right? If you have a threat modeling team that is not thinking like this and thinking of scale, they are part of the problem. Like, you know, being a bit politically correct, but you know, a threat modeling team that is not thinking about how they can scale, how they can automate, how they can codify the stuff that they do, is already not a team that is as effective as they could be.
So
right, Marius,
that brings me nicely to my few slides. I know we overrun, and I wanted Petra to make sure that she demos that, because it's a nice introduction and actually addresses my challenges as well. So I want to address when, who, what, why only in engineering, and my approach to all this. So if we go to the next slide, Petra, please. Mm-hmm. So one of the questions, when we have a lot of tools, and Petra just developed another way of doing threat model. We have another developer here that done automated threat models. We have companies that have a lot of software that do threat models. But in an agile environment, when do we do a threat model? When do we trigger a threat model? Have we really, as a security team, placed ourselves in the right place to trigger a threat model? Do we do it at the design phase? Is it time to do a threat model before code being shipped? When do we do a threat model from an engineering perspective? A new service, new functionality, new library, as the impacting authentication and authorization? So one of the biggest challenges I had in every place that I worked with when we do threat model, and you try to introduce threat modeling, is how do we inject ourselves to make sure that we do a threat model before code goes into production? And up to now, and I think Isa kind of made that comment, that threat model is a friction at the moment. And every place that I worked with is considered as friction, and is considered an afterthought that security push for. So that's something to kind of think about us as an industry on how do we best align ourselves with the agile method to make sure that we are doing a threat model iterative and on the new functionality or whatever that process is. So the second question I have is, if you go to the next slide, please. Who should be involved in a threat model? We've been discussing engineers. We've been discussing security engineers and developers. Nowadays, developers don't know the infrastructure because they basically consume that as a commodity for them. We don't include product owners. So we are sitting in a threat model as security engineers talking about threats, but we don't have the whole view from a product perspective, from a service perspective, from how the underlying infrastructure works. How can we make sure that we address risk and concerns and actually get the full picture when we don't even have the right people in the threat model? How do we make sure that we get all these people to join a session? I worked in a lot of agile environments that they're so siloed because their function is to consume APIs, to consume infrastructure as code, that they don't really understand the infrastructure they're running on. So if you're threat modeling a Lambda function, they don't know what permissions the lambda function has because they consume that from the DevOps team. So how do we thread model accurately when we don't know those, the whole picture? And again, you don't have one person that gives you this picture. The next question I posed is, what are we actually thread modeling in a thread modeling session? If we go and ask the developers to give us a data flow diagram, I'm pretty sure 90% of the developers will think, I've never produced a data flow diagram in my life. I'm not here to be designing data flow diagrams. I know how to code. I don't know the full flow because, again, I ingest infrastructure as code, which gives me a lot of different flows in there that I don't know. Any diagram for the infrastructure team looks different. For the development team, it looks different. What we require for a thread model is completely different. So how are we supposed to do a thread model when we don't even have a common language of what a diagram looks like? From a security thread model perspective, we need to see flows, we need to see processes, we need to see actors, but all those diagrams don't exist from a development perspective. Do we give them the responsibility to develop those diagrams, taking them away from actually doing the everyday day job? Or do we as security do this data flow diagrams, which means we spend and invest time to discover how the application works, bring all the other teams together to draw the information out and actually build a data flow diagram. So then the next question I pose, and again, there's a lot of questions and not really a lot of answers because it's challenges that are faced, and I have my approach that will cover, but these are a lot of questions that we, as an industry, I think we need to approach better. My next question that I posed, if you go to the next slide, Petra, is why do we only thread model an engineering process and engineering technology? As cybersecurity, as information security, as a business, do I really just care about the engineering? Do I just care about development? Why do we not thread model the business processes? We have common languages that we'll be developing for engineers and data flow diagrams that show infrastructure, but no one is speaking about how do we thread model the business process? How do we thread all the standard operating procedures? Human interaction. We can fall under attack with the human interaction. We don't have threat modeling scenarios, and there's no way of us raising risk. We don't actually, up to any of the threat modeling sessions I've been, looked at it from a different angle, apart from actors acting on the technology stack. All actors that we see is interacting with technology stack, not acting with the human aspect of the business, with the business process. If I can inject a business process into your company, can I hijack your whole company? Can I hijack your financials? Can I hijack your human resources team? We don't thread model this, and everywhere else in other industries, not security, we consider thread models for terrorists. We consider threat models for aeroplanes and aircraft, aviation. There's a lot of different threat models that happen out there that's not just technology focused. But when we talk about cybersecurity, we always look at it from an engineering perspective. We always look at it from a development perspective. We never look at the actual threats that could pose to the business from a business process point of view. And my last one, if you go to the next slide, my approach. And again, a lot of questions that I kind of trying to figure out as we evolved and mature in threat modeling. For me, it's trying to get threat modeling as the early stage of engineering, because engineering is where we are best placed at the moment as a company and as an industry. We are always closer to engineering than the actual business and process. So threat modeling as code, what Petra presented, for me is the new way of actually approaching threat modeling, get us closer to the development. One of the things that we keep trying to do is mature the threat modeling. But at the same time, we need to make sure that there's maturity levels for threat modeling. So a company that's small as Zava or as small as 5 users will not be able to do a threat model at the level of a tool that you purchase on the market. So we need different maturity levels for threat modeling. A company that has 0 to 5 will use the different methodologies and the different stages. Define what is expected in a threat model. I think that's quite important. When we bring together everyone on threat modeling session, we need to define what we expect them to bring to that. Is it diagrams? Is it a knowledge of the system? Is it the thread modeling methodology? So do they need to know Stride? All that we need to define what we expect them to do in a thread modeling session and teach them prior to a thread modeling session. Rather than spend the time on a thread modeling session going through Stride and explaining what Stride and what we're looking at, if they're required to know that, then we teach that prior to. There need to be a clear expectation of what do we do in a thread model. A thread model doesn't need to be perfect. That should be B, not half. Sorry for the dyslexia. We are too focused on making things perfect in the industry, but you don't get to perfect from stage 1. There's a maturity path. So I'm happy with a basic flow diagram that could do some thread modeling on, than having an automated way of producing all those threads. So we need to have that maturity level again and understand that we're not going to be 100% thread model everything from day 1. It's a maturity path. And my other approach is to make thread modeling fun brainstorming experience. Every thread model I've run or been a part of, I've learned so much about the application. I've left the thread modeling knowing that the engineers and developers have learned a lot more about how their code and what flows work better than prior to the session. Make it a fun brainstorming experience, and then you get that buy-in in. Post a lot of questions there, and I'm hoping we have some discussion at some point. I'm not sure if we have time on this session to how do we best approach all these questions? How do we make sure that thread modeling isn't a barrier to the business, isn't a friction, and we're actually achieving thread modeling at every stage that we need it to be?
Yeah, we've got plenty of time. Don't worry, guys.
I can see a comment there, thread model every story. I agree with that, but what does a story mean for every individual company? I can guarantee you a story for Zava is not the same for Glasswall, and is not the same for, what do you define a story for across the business?
Well, the question is every story that changed the thread profile.
Yeah.
Right.
From our perspective, yeah.
Because that's also how you scale. I do feel that a lot of the times the problem with threat modeling is that we threat model too much and we mix layers, right? And we almost mix abstraction layers. So I really like to think about your threat model specific, almost user journeys, use specific scenarios, or even an incident, right? You can create a threat model doing an incident, because doing an incident, you already got the answer. If this happened, you go, no, it just did, right? So you can already go to the next levels, right?
So retrospective threat modeling is always too late, but a good place to be, at least. But let's say a lot of the companies I work for, we a small security team that we can't threat model every service that's online or goes online. So we need to make sure that we prioritize what gets threat modeled, and we need to have a buy-in from the developers to include us at that stage.
Yeah.
Which at the moment as an industry, we are looked at as a barrier. So we will do anything that we can from a development perspective to say we didn't change functionality, to not have a threat model because my tight deadline is tomorrow for me to ship the code.
Yeah, but I think there's also, of course, culture needs to work, right? So for example, like, some of the threat models that Petra was involved, right? We had some spectacular case studies, right, of adding a lot of value in the design phase, right, before you actually even going to implementing stuff, where the threat modeling allow a number of questions to be asked, allowed a number of basically, design decisions to be challenged, so that we did it sooner rather than later. And actually, one of the things that we introduced recently, which I advise anybody to take a look at it, is we copy the Python enhancement proposals, and we basically created this thing for engineering called PEPs, well, GEP, sorry, which in this case is glass wall enhancement proposals, but you can call it, you can call it your ZEP, right, if you want to, right? But basically the idea is to create a definition of and a mini brief of what you want to do before you do it. And we got to the point where engineering is using it because it solves a lot of problems. And that's exactly where you want to put the threat models in, where you do the threat models as soon as you can, because you ask those questions, what is the design, what you want to do, right? But a lot of it from a functionality point of view.
Yeah, no, that's very true. We have also in Java, we have something called controls, and it's actually very similar in a concept of like, what are we achieving here? What is the design? And then we have some security questions that can potentially trigger a threat model. So that's like a good way to get this instilled in the design phase. Right. So we have Jakob and Isar. Go for it, Jakob.
You've just said what I wanted to mention.
Okay.
A kind of questionnaire that either makes the threat model a given user story or not. And at the same time, it is if questionnaire says that the risk is low or zero, then it is an actual threat model. I mean, you get the information that the risk is managed because there is no
Exactly. And that's why I have this little questionnaire at the top, because that can also be used as kind of like a checklist whether you should actually trigger the session or not. Because like some questions are, does this change your attack surface, and so on and so on. So if you do change your attack surface, then you should trigger a threat model. Isar, go for it.
So bunch of things, and please let me know when I start talking too much. So the thing with the trying to be part of a process at an early stage nowadays, and this is basically what leads me to threat model every story. Nowadays, we can't really put a pin on early stage, apart from when you are embarking in the whole idea at all. Because we have, for all intents and purposes, we have with the agile methodologies, we have promoted developers to architects. The developer gets a story, and they usually have so much latitude in how they implement that they may basically be altering the whole design going forward.
Yeah.
And then you don't have the option to going back to that initial threat model and say, hey, the design changed, let's change this whole thing. You need something that's actively changing all the time as the system changes, right? So that's, to me, that's the point of threat modeling every story. You have that agility to look at what's required, quickly decide if it has security value or not. If it doesn't, just go ahead and do the thing and move on. If it does, then document it, do a small threat model at the time, and deal with the consequences as they are, right? And that leads me to what's expected in a threat modeling session. I think that traditionally we have always expected a list of threats and the order that we're going to mitigate them. And that leads us then to what I believe Petra was saying, a list of what becomes requirements for the next round. Like we learned those issues on the previous one, so now let's put them in front of the process and say these are now requirements for the next round. And that's great, that's awesome. The thing is that requirements, again, have this way of sometimes, in some ways, putting things into a shoebox that some developers in the agile world would look at you and say, you are constraining me. So now you have a different battle to fight, right? Threat modeling doesn't have to be perfect. I couldn't agree more. And I think it's evolutionary by design. Yesterday, you didn't have a threat model. Now you have one looking back at what you did. Now you have one looking at what you have. Now you have one looking forward to what you're going to do. And each one of them represents a step up in your security journey. So you're getting better every time that you do one. And wow, that's awesome. And for the fun brainstorming experience, wow, there is so much to unpack in there. I mean, threat modeling can be a war. Threat modeling can be a game. Threat modeling can be learning. Threat modeling can be fun. And I think that, to me, in my experience of not one or two threat models, but more, the ego is the thing that mostly regulates how that experience is going to go. So if we are able to show to developers and architects, listen, I'm not here to criticize your system, I'm here to help you make it more robust, make it more secure, then that's where you start making that thing a fun experience for everyone.
Couldn't agree more.
Sorry for talking so much.
Couldn't agree more. Ego and rewarding, the two aspects of a threat model, I think that if you get them right, then the session ends up being very productive and everyone lives with the buy-in and they want to do the next one. Again, it's very, very important not to go to threat modeling and feel threatened that someone's going to basically blame you for developing something insecure or having a threat in a live component that wasn't threat modeled. It's about learning, it's about gamifying it, and it's about making sure that everyone's got this threat actors mentality built into them. What can go wrong? And I think that's really important to gain out of that brainstorming session. And I totally agree about early stages. And that's one of the, when I put early stages there, I think that's one of the biggest challenges is what do you call early stage? SDLC, it's nice when it's waterfall. When you're speaking about agile, the reason an iterative way sometimes is just the architect, the infrastructure, and everything sits on the developer. So they decide what to and how to implement. So that for me is one of the biggest challenges, because the developer can decide that this is not a big piece of work, is only iterating on an existing code and not deem that threat model needs to happen and basically change how authentication authorization work and introduce vulnerabilities there, and we never threat model the new piece of code.
Yeah, I couldn't agree more on that. Especially, I also want to add on the egos and making it fun and gamifying it. Sometimes it can also be a fine balance, right? You want to get to that developer competitive side that they start kind of like thinking about all the ways how they made it good, you know, to show us, oh, you can't actually do this because I've implemented, you know, an API key on that endpoint. You know, so it's a fine balance between making the developer challenged and feel competitive, and also at the same time not feeling like their ego's been stepped on. So I guess, you know, it's a thing maybe with experience, the more you do them and the more soft skills you acquire and the more you can read people, it's kind of going to become like a soft skill process as well, where you can try and get that fine balance. Where you want to make it fun, but not threatening. Cool. Thank you, everyone. This was a great discussion. Has anyone else got any?
Yeah, Pat, let me just add a couple more notes on this topic, right? I feel that it's important on threat modeling to understand what phase and almost what the objective of the threat modeling is, right? There's some threat models that the objective is to basically, you know, almost start showing the value of the threat model, right? And I think when you do those, yes, you have to be very sensitive, but ultimately you're doing a pen test on paper, right? You basically, you know, using the threat model as a way to reverse engineer. In fact, doing a threat model before a pen test or security review is really good, because sometimes the areas that the developers are very comfortable is the areas you want to start first, right? Because sometimes, you know, you can see by how somebody explains the solution that they don't understand the problem. So it's much easier to sometimes have evidence. But I feel today, a lot of the conversation we have is how do we scale threat model, right? How do we take the people that are convinced that they want to do threat models, us, right? A lot of the security professionals, how do we make it scale? And I think on those, I think it's very important that you reverse engineer how the organization works, right? There's no point of bringing, you know, a lot of new practices. It's almost like find the sweet spots. There's enough stuff to do anyway, right? Until you get a practice, until you have the problem of how do I really make this scale, which is how do you get the security champions to do the threat models and you on the receiving side of it. The beginning is about reverse engineer the organization, understand where is the sweet spots, where there's budget available, where there's focus, where there's time, and then you align yourselves with it, right?
So yeah, that's for me, when you go to an organization, you can't bring a threat model methodology or a way of working without actually understanding how the organization is structured and works. So reverse engineering, where can you inject yourself? Has to be that you're learning with every role that you take the experience, but then be malleable on how you implement that in new organizations.
Yep. Absolutely.
Yeah.
Great session. So there you go. There's a great, I don't know, let's keep having a check-in every 2 months, right? So, you know, come back, you know, but I feel that we really need, and I really hope that with this, you know, these two projects, right? Like, you know, we really need to move, I think, the conversation of threat modeling from the why and the what to basically, it's almost like the how to just the what, right? I really feel that we need to start to have a common library of patterns that even we can do during this summit or other examples where we can say, here's a threat model of a particular, even like take a vulnerable application, right? We can take, you know, I think we even did some threat models in the past on top of the juice shop, right? I think we really need those templates so that, you know, when we go to a team and saying, hey, do a threat model, they can know what good looks like. Because every single case where threat modeling has scale, it doesn't scale for the first 5 and 10. It scales because the 11th, 20th, 30th, 40th threat model copy the one before, right? So we need to start to share those things so that when my biggest frustration is some of my best threat models I could never share because there's a moment where the threat model clearly indicates the problems and the design decisions that we have, right? So we need to create a common open source Creative Commons base of threat modeling examples. And there's some things out there like threat modeling cookbooks and stuff like that. Let's just build that momentum so we can do lots of sessions where we just look at a web app and we look at a backend integration, we look at a legacy app, we look at a payment system, we look at almost like case studies and then get everybody to almost use these technologies to create these templates that we can share.
Yeah, I agree. Let's maybe next time around, let's try and do a threat modeling session with this method and create an actual. So
exactly.
Let's do it.
Thanks a lot.
Cheers. Thank you, everyone.
Thank you.
And this will be also on the YouTube channel, right?
Yes.